Hello and welcome to another video. Today we're going to be continuing talking about circles. As always, my name is Mr. Keeney, and really I'm just saying that so I get an excuse to write with this really cool stylus that I got now. So, like I said, anyway, we're going to be talking about circumference and arc length today, which is actually our third lesson out of Unit 9. And this unit, to remind you, is about circles. So let's go ahead and get started. Circumference. So, kind of makes sense. If we're going to talk about circumference, we should probably know what it is. And circumference is the distance around the circle. And you can kind of see it here with this little arrow. It is the distance around the entire circle. So when we are dealing with circumference, it's almost like the perimeter of a circle is what a lot of students tend to think of. We can find the circumference. We have a nice little formula. C circumference equals 2 pi r, r being the radius, which you can see is right over here. The radius we've talked about earlier in this unit, so if you need to go back and review some of the earlier videos, you can do so. But radius is the distance from the center of the circle to the circle. Now we have another equation or another formula for circumference. We have 2 pi r, but when you think about it, if you think about 2 pi r, 2 times r is the diameter, which is right there, diameter. It is a chord, again, another vocab term we've talked about. It is twice the radius, but it goes from circle to circle. The endpoints of the chord are on the circle, and it goes through the center. So instead of having 2 pi r, we can actually write not 2, pi times diameter. So either of these two formulas will work. Let me put an or here so you don't think that they're different. You can use circumference equals 2 pi r or circumference equals pi times diameter. Either way, it's equivalent. These are equivalent expressions or equations. I can't talk right now, so let's just go ahead and move on. Now we have circumference and arc length. And arc length right here says the length around an arc, meaning it is still on the circle. So we're going from point A to point B, and we're on this red part here. We're not a segment. It is quite different than a segment. It is not the shortest distance. It is around the arc. So it is a part of the circumference. So what you would think, this curved distance right here, if we're talking about arc AB. Now we can find arc length, which is different than the degree measure. We can actually find that distance like we can find circumference. We're actually going to use circumference. The circumference of the circle, which was talked about, was 2 pi r. Okay, so I just told you how the length of an arc, or this AB right here, I just keep drawing on it, it is a portion, as you can see, it is only part of this whole circle. I'm only concerned about this part. So if I want to find the arc length, and let me go ahead and write this down here, it is going to be length, I can spell arc length, there we go. Arc length is going to be a portion of the circumference. And as you can see, I've formed a ratio here, the arc length over the circumference. Circumference, I went ahead and plugged in that formula, 2 pi r. Now, how are we going to use this? Well, if we have the radius, which sometimes we will, that'll be a good start, but still, when we solve, and what we've done this year is, if we have a ratio, we usually set up a proportion. So, what would we relate this to, or what would we say this is equal to? Now, when we have, and let me go ahead and change colors here, when we have 2 pi r, we have a full circle. A full circle has 360 degrees. 2 pi r is the total distance around the circle. 360 degrees is the total number of degrees in this circle. So when I look at the circle here, all the way around is going to be 360 degrees. Go ahead and get these points off here just so you can see better. So arc length is only going from the radius to the radius that form the central angle APB, meaning 360 degrees is going to be related to the degree, oh my goodness, handwriting, degree of the arc. which, again, why we have this sequencing in geometry. We went and we talked about degree measure of arcs before we got to arc length, and then after this we're going to talk about areas of circles and sectors. But the measure of an arc, the degree measure of an arc, is still relevant, and we're going to use that to find arc length. So let's go ahead and jump into examples. That is about all you need to know as far as vocab and terminology and all that good stuff when it comes to formulas, equations, yada yada. So, first example, pretty simple. You've probably done this before. Find the circumference of the circle. If we're going to find the circumference of the circle, we should probably use the formula, which is circumference equals 2 pi r. R standing for radius, which is exactly what they give us at 7 centimeters. So you simply take this formula, circumference equals, we're looking for circumference, 2 times pi times 7. So I'm going to go ahead and leave this in terms of pi. So circumference equals 2 times 7 is 14 pi, and then it is centimeters is our units, and this is a distance. It's not area, it's not volume, so we're just talking about a first dimension here, just a length. So this right here is our answer. Our units is just centimeters to the first power, and that would be how you find the circumference of the circle. Another example that you've probably seen before is this right here, and we're going to go ahead and use a circumference formula, but we're actually going to use it. They give us right here, this is a diameter because it is got endpoints on the circle, if I can get the other endpoint, and it goes through the center. So I'm going to use pi times diameter because they give us diameter. And this actually makes it really, really simple. Our circumference is just 13 pi, and then inches. Our unit is inches this time. I'm going to leave it in terms of pi. If we need to evaluate this, we would round it 2 decimal places, and we would just put 13 times pi in the calculator. I'm not sure exactly what that would get us right now. I might have to get out a calculator here in a second if I would like to. But until that point comes, let's go ahead and go on to the next equation, or next example problem. This one says find the radius, so this is a little bit different. It says find the radius, should be interesting. Round to 2 decimal places. We may or may not do that. I'm going to go ahead and scratch that out for a second. Find the radius. They give me the circumference. Usually, back in this problem that we just did, we were looking for the circumference. Now, they give it to us. So, let's go ahead and use the circumference. And to do that, we're going to use its formula. Circumference equals 2 pi r. But this time, we are looking for r. The circumference is 48, and we have 2 times pi times r. So quite simply, we just now have to get r by itself. So we would divide by 2 pi, divide by 2 pi, and this might be one where we're going to have to use our calculator because 2 pi will cancel over here, leaving with this r. And then I can do 48 divided by 2. That's going to be 24 divided by pi, which is terms of pi answer, I guess, and we could put inches on it if we wanted to. But for our people that want to actually, get something that looks a little bit more like a radius, let's see, I got my calculator over here, 24 divided by, and I got to see if I can find the pi button. There it is. And that would be around 7.64 inches. So I went ahead and I followed the directions, set around to the nearest 2 decimal places, and so that's what I did. And all I did to do that was I put 24 divided by pi into the calculator, and that it would give me 6394, so that rounded to 7.64. But we were able to, the key thing here in this problem was going back to this formula, circumference equals 2 pi r, and more specifically, I was using it to find the radius this time, because again, they gave me, down here, they gave me the circumference. So the missing information was actually this radius over here. So, on to the next one. Find the perimeter. Oh, what a weird looking problem here. So, perimeter is just the distance around this shape, which this is kind of a weird shape. I don't even know what we want to call this, but it doesn't look too bad. They tell us that this is 15, so this one up here is going to be 15 as well. And I think this 9, they're telling us that the diameter, they would have to, the diameter is 9. So and going over here, that means this diameter would be 9 as well. Okay, so let's go ahead and see what we can do here. Clearly we have these two sides, 15 and 15. That's going to give us 30. So if I'm trying to find the perimeter, let me go ahead and put down 30, and then I'm going to have to add on something. And I'm going to change colors because I'm going to deal with the circles here for a second. Let's go with a purple. So these circles, I have two circles that are kind of, for circumference-wise, I'm using half of it. So I'm using this part of this circle's circumference, and I'm using this part of this circle. And I'm ignoring the other half because that's not on the outside of the shade. That's not going to be part of the perimeter. But putting those two parts together gives me a whole circle with a diameter of 9, because those two circles are congruent, they have the same diameter. So really, if I can find the circumference of the circle I created down here, which is 2 pi r, then, and actually, you know, there's Mr. Keeney, let's make that easier, Mr. Keeney. Instead of 2 pi r, let's use pi times diameter, since they give us the diameter. So the circumference of the circle is just 9 pi. So back to the perimeter, I have 30 because I took 15 plus 15, and now I know that if I have this purple parts right here, because I've already covered this, 15 covers this top part and this bottom part. So now if I account for all the purple parts that I've kind of shaded in for you, which that purple part for the circles is 9 pi, then I'll get my perimeter, which actually here, it looks like if I want terms of pi, 30 plus 9 pi units is perfect. So that would actually be our terms of pi. But for the people that are wanting a little bit more, something that they can see a little bit more concrete, we'll say, I don't know if that's a proper term there, but we'll go with it, it sounds good. Let's go ahead and get this decimal here. So if I do 9 times pi, that'll get me, it's a 30 plus, bringing down 39 pi is about 28.27. So let's go ahead and add those together, and our perimeter, and again, this right here would be perfect for terms of pi. But 30 plus 28.27, we just do a little math, 58.27 units. And not squared, not cubed, it is just simply units. They didn't give us units, so that's why I said units instead of like inches or centimeters. So kind of a weird problem, but we just used two really semicircles, I guess, to figure out what the circumference of that total circle would be to get our perimeter. So kind of a weird problem, but I like it. I like it. Moving on. Oh, I erased the directions, so I'm going to kind of fill you in. What we're going to try to find here, we're going to try to find a length of AB. We're going to find the length of arc AB. So how we do this, to remind you, is that I'm going to use, well, I don't even know about use, but I have circumference that I know I can always find, and I know that the circumference of a circle is the whole 360 degrees around a circle. And now let's look at arc AB. Arc AB, well, the length, I'm trying to find that. This is going to be like my X up here. And the degree of this arc is, and we can go over here, might be a good time to change colors though. Let's go to a blue. It is 90 degrees. And I know it's 90 degrees because if I look at its central angle, it's a right angle, so that right there would give me a 90 degree arc. So this would be 90 degrees. And the only other thing I need to do is they give me a radius of 7, so I can change this proportion right here. Instead of 2 pi r, well, 2 pi times 7 is just 14 pi. So let's go ahead, and I'll just use my eraser tool for the heck of it right now. I'm going to erase 2 pi r, and I'll put in its place what we know the circumference to be, which is 14 pi. And this is where we can use cross multiplication, we can simplify some fractions, we have a lot of options going on. So actually what I am going to do is I'm going to simplify the right side of this equation. I'm going to keep x over 14 pi for right now. And I'm going to 90 over 360 is simply 1/4. So I am now going to, sounds like it's a good time to change colors, I'm going to cross multiply. If when I do this, and I'll bring this over here, x times 4 is 4x, and 14 pi times 1 equals 14 pi. So let me kind of block this off so you know what I'm doing. So now I'm trying to find x, so I will divide by 4, divide by 4, 4's cancel out, x equals, and let's go ahead and leave this in terms of pi, why not? So that'll be 7 pi over 2, and it would be inches. This will be the terms of pi for my people that want the approximate value. I don't know why I keep doing this for you today, because I like terms of pi and it'll help you out in the future. But let's see, let's just humor ourselves here. So, and my calculator is not wanting to cooperate. 7 times pi will get us 21.99 about, so then we do divided by 2, and it gets us 10. Oh, I guess that's really, now that I look at it, 11.00 technically inches. So it's not exactly 11, but it's pretty darn close. So close enough to where when we round to 2 decimal places, it gets us right there. So the arc length, AB, ended up being about 11 inches, or 7 pi divided by 2 inches. So we found it. And what we did was we set up a proportion using circumference, and the total degree of a circle being 360. So let's go ahead and move on. Oh, and now we're on to, these are, and I'll go ahead and tell you, these are homework problems for the people that are watching this, and if you're in my class, this is a homework problem. Find the length of the indicated arc, which is this little, it looks like it didn't, I don't know what happened there, but we're going to find what I just did, a highlight of that red arc, and it's they're going to be the same setup. We're going to use the circumference 2 pi r, and actually, instead of doing that, let's go ahead and find what 2 pi r, the circumference, is going to get us, because I see here my radius is 16, so that would be 2 pi times 16. 2 times 16 is 32, and so we have 32 pi. So circumference 32 pi, and always a constant for us is 360 degrees for our circle. This time, if I'm trying to find the arc length, which is going to be x, my arc degree measure is 240. So let's go ahead and, when I see, and let me go ahead and highlight over here, that part right there, if I can reduce that and make my cross multiplication easier, I will. It's just going to make life easier on me. Usually I can reduce these over here. If I can reduce this, I will, because I feel like I just said the same thing over and over, but it's just going to be easier doing the work on the front end than dealing with it later. So x over 32 pi I'm going to keep for right now, and 240 over 360, well, I can take off the 0, so that's just 24 over 36, and looks like 12 goes into 24 2 times and goes into 36 3 times. So really I just have 2/3 that I have. Now when I cross multiply, and let's switch to a nice purple, because I like purple, x times 3 is 3x, and 32 pi times 2, which is a lot more friendly than doing 32 pi times 240, that is going to be 64 pi. Divide by 3 on both sides. These cancel out, and so I get x equals, and I think 64 pi divided by 3, yep, that is going to be this, and let's see, feet. That is going to be my arc length for terms of pi. Let me see if I can get a, and which I say let me see if I can do it. Let me just use my calculator real quick, because I am not getting any pretty answers for some reason, which is fine. We just do 64 times pi into our calculator, which I got about 201 and some change. Divide that by 3, and it looks like our arc length is 67.02, and then feet. Looks like I didn't give myself room. So either way though, big thing here is this, I reduce this, I make it into 2/3, and I just did that by reducing the fractions. Your calculator will do that for you, and that's just a skill you should know by now, is reducing fractions. Cool, I think we got one more, and again, this is a homework problem. If you are one of my geometry students or honors geometry, for this and this homework, it will work for both. This is a homework problem, so is the last one. Thank you for watching. If you're here to check your answers, great. If you're here to learn. If you don't have me in class, then hello, my name is Mr. Keeney. Anyway, this video is it's 20 minutes long now, so let's get going. Let's find the circumference, because we know we're going to use that. This time our radius is 10, so 2 times pi times 10, so my circumference is 20 pi. Cool. So 20 pi is our circumference, and that is for the whole 360 degrees of a circle. I am trying to find the arc length of an arc that has a angle degree measure of 60 degrees, because the central angle is 60 degrees, so 60 degrees. And again, and I'll go ahead and switch colors because I love colors. I can reduce this. That is going to be so easier for me to just reduce it right now. So I'm going to keep x over 20 pi again. As you can see, these problems are pretty structured. 60 over 360, which is 6 over 36, which is 1 over 6. A lot of ways you can do this. Now I can cross multiplies. Why not change colors again? What have we not used today? How about like a pink? X times 6 is 6x. Is that pink? Yeah, that's close enough, but that's a terrible x. 6x, and then 20 pi times 1 is 20 pi. Why would I ever get a whole number pi in terms of pi? And I made this homework too, so, you know, whatever. Or maybe not made it, I assigned it. These cancel out, getting me x. I'm going to go ahead and take this up here so we have a little bit of room. X would equal 20 over 6. What is that? 10 over 3. So 10 pi over 3 inches. Or if I want to get an approximation, and all I have to do now is put 10 times pi in my calculator, which is about 31.415926, because it's just pi, and divide that by 3. And my final arc length that we're going to find for this is 10.47 inches. I just completely lost where I was in life, which happens a lot more than you guys think. But that is it for today. This has been another video for arc length and circumference. I'm going to use this blank slide right here to write my name. My name is Mr. Keeney. If you are watching this and you're one of my students, thank you for taking the time. Thank you for trying to learn, for putting in the effort, or for just watching because you know you like math that much. I know I do sometimes. If you have any questions, if you're one of my students, you know how to reach me. If not, you can leave comments down below. We love comments. And if you really need to get in touch, I'm sure that you can send me either a private message, or there's some sort of, I don't know YouTube very well. I'm a teacher. But thank you for watching. You guys are great. And always, as always, hopefully I learned you today. So have a great day. And until next time, goodbye.